And for today's episode, we have section 5.2, the definite integral. And the definite integral means that you have a function over a definite interval, like from a to b. And then let's say the function looks something like this. Just make a nice function, f of x. And then drop a line straight down to b, drop a line straight down to a, and then shade that area. And the area is equal to the definite integral. So in the previous section, Riemann sums, we would divide this into subintervals and then create rectangles to estimate the area. And now we're talking about the actual area. So that is symbolized with this symbol, which actually comes from a big S for sum. In other words, sum up all of those rectangles or sum up the total area. This is also called the integral symbol. Integral means, or to integrate, means to put together. So you're putting together all of those little pieces and adding them up. And then you need to tell it go from A to B. So the A starting point goes down here. The B ending point goes here. And then in here, there's going to be f of x times dx. So in the previous section, we did some sequence for this. And then this was the height of each rectangle, and this was the width of each rectangle. Because dx and delta x are the same, but in the integral notation, we use dx. So that is the actual area. Now some facts about area, or facts about integrating, in no particular order. So one is, if the function is positive, then, or bigger than or equal to zero, then the integral, or the area, will also be bigger than or equal to 0. If the function is negative, then the integral will be negative. Now in real life, there is no such thing as negative area, but it just means that it was underneath the x-axis. So above the x-axis would be positive. If it was underneath the x-axis, it would be considered negative. Much like in a business, they could have 1 month where they make money, another month where they lose money. And when you add those 2 months together, hopefully they made a profit, but there's no guarantee. Another useful one is if k is a constant, then if you're integrating from a to b, k times the function f of x, then you can just factor out the constant k and then integrate the function and you'll get the same answer. So that is a fact that we use a lot, factoring out a constant. Another one, which doesn't show up very often, but what if you integrate from A to A? So in other words, what's the area from here? And since it didn't go anywhere, then the area just here is 0. And then another fact is, suppose that you were asked to integrate from the small number a to the bigger number b. But then you accidentally switched them and you went from B to A. So you were asked to go from left to right and you went from right to left. Well, what will happen is you'll get negative of the answer you were supposed to get. And then suppose that, here's the same picture of the function. And then suppose that there's some number in the middle c. Well, if you integrate from a to c, you find this area. And then you integrate from c to b and find this area. If you add those two areas together, then it will be as if you integrated from a to b. So the integral from a to b is the same as integrating from a to c, and then adding in the integral from c to b. And there are some times when we need to break it up into two integrals. Okay, now, for example, number 1. So we're going to do two things. One, estimate the integral of sine of x going from 0 to pi using 100 rectangles. Then find the area between the function sine x and the x-axis on the interval from 0 to 2 pi. So this is the Riemann sum, just like we did in section 5.1. So the x-axis is going to go from 0 to pi. So I'm working on this part right now. And then we need delta x. So that would be pi minus 0 over 100. So delta x is pi over 100. That means this first interval goes from 0 to pi over 100. For the last interval, this would be 100 pi over 100. So if you move over, this is going to be 99 pi over 100. And in here, I forgot to specify, so I'm going to use the midpoints. That is the more accurate way to do it, so I'm going to use midpoints. So in the middle of these two would mean that you add them together and then divide by 2. So that means that you actually just cut this in half, which is going to be pi over 200. Then to find this midpoint, you could add those two and divide by 2. Or you could say the length in here between this tick mark and that middle point is a length of pi over 200. So I could take pi and then subtract pi over 200. Well, I'm not going to put the pi on the calculator. I could just take off the pi, and that would be a 1 minus 1/200th. So 1 minus 1/200th is 199 over 200. So this one is going to be 199 pi over 200. And now we use the sum sequence. So it's going to be the sum sequence. The function is going to be sine of x, and then multiply with the delta x, which is pi over 100. And then x goes from pi over 200 to 199 pi over 200, and delta x is pi over 100. So go to second list, math, and get the sum. Second list, operations, and get the sequence. And then it's going to be sine of x times pi over 100. And then x goes from pi, that's not pi, pi over 200 to 199 pi over 200. And then this should be pi over 100. And we should get an answer close to 2. Very close. 2. Excellent. All right, that was the first part. But the real goal was find the area between sine and the x-axis between 0 and 2 pi. So if you were to use the calculator and just go graph sine, change the window, go at least to 2 pi, so 2 pi plus a little bit, and then the y value from -1 to 1, and then if I use the calculator to find the area, that's going to be using number 7, integrate, from 0 to 2 pi. And it shades the area and says all of that blue area adds up to 0. That is not the correct answer. The correct answer is 4. So if you just integrate from 0 to 2 pi, well, this is going to be positive 2, and this is going to be negative 2, and that's how you get the answer 0. But this question was saying find the area between them. So that means that when we did this work, we got this area and this was a 2. And because the graph is symmetric, this area would be 2. So that means that the total area is equal to 4. So sometimes it will ask for the total area, in which case the positive, you could just leave positive. This, which was a -2, I then have to take the negative off, and then you add the two together to get a total of 4. If the problem just said, I want you to integrate from 0 to 2 pi, then that positive 2 and that negative 2 will cancel each other out, and you get 0. Much like a business, one month they make $2 million, the next month they lose $2 million, so over the 2 months total, they broke even 0. All right, now on to the next example. So for example number 2. So how about if you were integrating from 0 to 1? So estimate area using n equals 50 rectangles. So I don't really need to draw the function, but I do need to look at the x-axis. So the x-axis would be going from 0 to 1. And for delta x, you subtract those two numbers, so 1 minus 0. And then that gets divided into 50 pieces. So each one is going to be 1/50th. Now, with the other examples, if you consider 5.1 and 5.2 so far, I've been using fractions. But now I want to use decimals. So what if you decide you want to use decimals? So 1 divided by 50 is 0.02. So this first interval is going to go from 0 to 0.02. Then the last interval. So you have to move over to the left by 0.02. So that means this is 0.98. And I forgot to say midpoint, but I prefer to use midpoints. So what are the midpoints? For this one, you cut this in half, and the midpoint is going to be 0.01. Right in between a 0.98 and a 1.0, that's going to be 0.99. And then the sum sequence. So add up. The height will be the function 1 plus x squared. And then that gets multiplied with a 0.02. X is the variable. It starts at 0.01. It goes to 0.99. And this last part is always delta x. Second list, go to math, find the sum. Second list, go to operations, find the sequence. So this is going to be 1 divided by, and then I need parentheses, 1 plus x squared, parentheses, and then that gets multiplied with 0.02. And then start at 0.01, end at 0.99, and the step is going to be 0.02. So the answer is 0.785. And usually at this point, what I would say is, let's go ahead and graph it and have the calculator find the answer. But I have another way to find the answer. This means find the antiderivative of 1 over 1 plus x squared. Or in other words, what function is it you would take the derivative of, and the derivative equals 1 over 1 plus x squared? You're right, that's tangent inverse. Now we also have the limits from 0 to 1. So to indicate that over here, you then draw a straight line after it and then say from 0 to 1. Then you start at the top and plug that number in. So it's going to be tangent inverse of 1 minus tangent inverse of 0. And then do you remember tangent inverse of 1? You're right, that's pi over 4. Tangent inverse of 0 is 0, which means that the actual answer is pi over 4. Now let's see how our estimate compares with pi over 4. Pi divided by 4 equals a 0.785. So this is the actual answer, 0.785, and our estimate was right on. Now, if it was up to me, we would be done with this section, but I need to do one more because of the way they ask questions in the homework. So for example, number 3, they have a few that are like this. So instead of giving you an explicit function like 1 over 1 plus x squared, they say, here is what we know about the function. These are going to be the x values, these are going to be the function values. And so x is going to be 5, 7, 9, 11, 13, and 15. And the y values are going to be -6, -3, -1, 1, 5, and 7. And then find the upper sum and the lower sum. So when you when you use this interval as you're going from 5 to 7. So as you go from 5 to 7, and the function would actually be negative, so it would be down here. So when you use this interval right here, you could use the left endpoint, the right endpoint, or the midpoint. And the lower sum means you should use whatever gives you the lowest number. Upper sum means you should use whatever gives you the biggest number. So for the integral that goes from 5 to 15, okay, so when we go from, I think it would be better if I draw more of the picture than just that. So 5, 7, 9, 11, 13, 15. So we have 1, 2, 3, 4, 5 things that we need to add up. So when you're using this interval from 5 to 7, so at 5, when x is 5, then the y value is down here at -6. And for 7, it's right here at -3. So when we're doing the lower sum, then you pick the lower out of these two numbers. So for the lower sum, it would be use the lower one, which is -6. So it's going to be -6, and then times the width, which is 2. So that basically means we're using this rectangle right here to estimate the area between the function and the x-axis. So then move on to the next interval, which goes from 7 to 9. So for 9, it's at -1. And so between 7 and 9, this is the lower one. So then we're going to use -3, and its width is 2. And then between 9 and 11, well, 11, its dot would be right here at 1. And so for this interval from 9 to 11, the lower one, out of these two, the lower one is this. So use -1, and the width is 2. And then between these two, for 13, it's up here at 5. So the lower one is this one. That's going to be 1. So +1 times the width of 2. And then for 15, its dot is up here at 7. So the lower one is that one. So use the 5. So +5 times 2. And then how much is all of this? So this is -12 -6 -2 +2 +10. So that would be, well, these two will cancel each other out. This is going to be -18 +10, so that's -8. That's the lower sum. Then for the upper sum, so now I think I can do it a little bit faster, because it's basically saying when you're going from 5 to 7, which one is the bigger number? That's going to be the -3. So you would have -3 times the width of 2. Then you go on to the next interval from 7 to 9. Which one's the upper number or the bigger number? That would be the -1. So then it's going to be -1 times the width of 2. And then between these two, between 9 and 11, the bigger number is the 1. So it's going to be 1 times the width of 2. And then for these two, the bigger number is going to be the 5. So +5 times the width of 2. And finally, between these two, the bigger number is 7, so use plus 7 times the width of 2. And then this would be negative 6 minus 2 plus 2 plus 10 plus 14. And the 2's are going to cancel. 10 minus 6 is 4, and then 4 plus 14 is 18. So the biggest the sum could be is 18. The lowest the sum could be is negative 8.